Okay, this is lesson 7.2. And the lesson is called Solving Problems with Proportions. So the first thing we need to do is find out what proportions are, okay? So a proportion is a statement that two ratios or rates are equivalent. Okay? So basically 1/3 and 2/6 are equivalent ratios. And you know that because you get an equivalent ratio by multiplying the top term and the bottom term times the same number. You multiply 1 times 2, you get 2. You multiply 3 times 2, you get 6. So you know those are equivalent ratios. So the way we would write a proportion is like this. 1/3 equals 2/6. This is a proportion. Okay? It is a statement that says two ratios or rates are equivalent. 1/3 equals 2/6. That is a proportion. Okay? So we're going to use proportions to solve problems. So let's try that. Let's do a problem together. Allie can run 3 miles in 36 minutes. At this rate, how far could she run in 60 minutes? We're going to solve by setting up proportions, right? So the first ratio I like to set up is the word ratio. And this helps us keep things in the right places. So we're going to do miles. And then on the bottom of the ratio, we're going to do minutes. And this helps me to remember that I need to keep my miles on top, 3, and my minutes on bottom, 36. And here's where I set up the proportion. This ratio is, I need to find an equivalent ratio that has 60 for the minutes. So I'm going to put 60 where the minutes go. And now I have to solve for the missing number. Now, remember from the last lesson, the way we do that is whichever two corners, if you have two corners, the 3 and the 6 are the two corners that are across from each other. We're going to multiply those two numbers, okay? So 60 times 3 equals 90. And then what we're going to do is we're going to take 90, the answer, and we're going to divide it by the third corner, okay? So we're going to divide by 36, right? So 90 divided by 36, remember in this module, module 7, module 6 and 7, that's when we started to be allowed to use calculators. Modules 1, 2, 3, 4, and 5 were no calculators. Starting with module 6, we are allowed to use a calculator. So I'm going to get out my calculator and I'm going to do 90 divided by 36. And I get 2.5. What that means is, Allie, it says, how far could she run in 60 minutes? We put the 60 down here where the minutes go, and we got the answer 2.5. So Allie can run 2.5, which is 2.5 miles in 60 minutes. That would be our answer. Okay, Allie can run 2.5 miles in 60 minutes. So that is an example of using a proportion to solve a problem. And remember, a proportion is when you have two equivalent ratios. So there is a place where we use proportions a lot, and that is in a situation called scale drawings. Okay, so what is a scale drawing? A scale drawing is a drawing of a real that is proportionally smaller than the real object. So sometimes we might draw a picture of a friend. Well, the picture is obviously much smaller than your real friend, right? You're like the real person. So a scale drawing would
be a drawing that is proportional. When I draw, I don't draw very proportionally. Sometimes I try to draw a person and the head is way too big compared to the body. That means it is not proportional, right? It's not the just a smaller version of the real person. It's all messed up. So if the drawing is actually proportional, it is a smaller version of the real thing. Okay, it's not all out of whack with too big of a head and too long of arms, right? It is actually proportional with the way the real object actually is. Okay,
so a map is a really good example of a scale drawing, because a map is a drawing of the roads and the area, and it is to scale, which means it is a smaller version of the real road. And it's not like on the map, the road looks way longer than it really is compared to like a house, for example. Okay, so the scale of the map is the ratio that compares the drawing to the real object. You have to keep that in mind. The ratio is always going to compare the drawing to the real object. So when we do our word ratio, we know that on the top, we're going to have either the drawing, and then on the bottom, the real object. Okay, so the distance between two schools on Lay Avenue is shown on the map. So here's the map, and here's Lay Avenue. See the word Lay Avenue? So here's the road right here. And here's one of the schools, R, and here's one of the schools, P. And the distance is shown right here. It says 3 inches. All right? Now on the map, that's 3 inches. In real life, the road is not 3 inches long, right? Just on the map, it's 3 inches. So what we have here is a scale. The scale says that 1 inch on the map is the same as 2 miles in real life. Okay, so 1 inch on this map represents 2 miles in real life. So that is the scale, which is the ratio that compares the drawing to real life. So the drawing, 1 inch, compared to real life, 2 miles. Okay, so we want to figure out if it's 3 inches on the map, how far is it in real life? Okay, let's want to know if can I walk there? Can I walk from one school to the other, or is it too far? Which means I need to know how many miles it is in real life. Okay, so we're going to write a proportion. And the proportion is going to be, first of all, the scale is 1 inch, right, compared to 2 miles. That is the scale. We're going to start with that scale, and we're going to write a proportion, and we're going to try to figure out how many real miles is 3 inches. From here to here is 3 inches. So we're going to put 3 inches on the top, and we want to know how much is that in real life in miles. So we're going to now solve for the missing number. And again, we're going to do that the same way we've been doing it. We are going to multiply the two numbers. This time, the two numbers we have across from each other are here, 2 and 3. Those are across from each other in the corners. Then 2 times 3 is 6, right? And then we're going to divide by the third corner, which is 1. 6 divided by 1, right? 3 times 2 equals 6. And we're going to take that 6 and divide it by 1, which is 6. So this question mark is 6. What that means is the school R and school P, the schools are 6 miles apart in real life. 3 inches on the map, 6 miles in real life. Okay, and this is how we use proportions to solve scale drawing problems, right? There's a lot of places in real life, like maps, where we use proportions. Okay, and that is lesson 7.2, where we are solving problems using proportions.